Welcome to my channel. Please subscribe. XMPP, Extensible Messaging and Presence Protocol. XMPP is a communication protocol used for exchanging data in real time. It is designed for sending small pieces of data known as stanzas, and it is used in instant messaging, IM, video, and voice calls. XMPP is an open standard protocol, and it is designed to be extensible, which means it can be adapted to any application. XMPP was originally named Jabber, and it was created by Jeremy Miller in 1998. It has since evolved into a robust communication protocol that is widely used in IoT applications. XMPP is built on top of the XML language, which provides a way to structure and organize data. Each XMPP message is composed of XML elements that are used to represent data such as messages, presence, and data forms. The protocol uses the client-server architecture, where a client sends a message to a server, which then forwards the message to the intended recipient. XMPP also supports peer-to-peer communication, where a client can send a message directly to another client without the need for a server. One of the most significant advantages of XMPP is its extensibility. Developers can add new features to the protocol without changing its core functionality. For example, XMPP can be used to support real-time data transfer, voice and video calls, and IoT applications. XMPP is also highly secure, as it uses TLS encryption to protect the transmission of data. Additionally, XMPP is supported by a large number of clients and servers, making it easy to find tools to use for development. XMPP has several use cases in IoT applications, including device control, data transfer, and notification services. For instance, XMPP can be used to control devices in a smart home, where a user can send commands to devices using an XMPP client. XMPP can also be used for real-time data transfer, where sensors can send data to a central server in real time, enabling quick response times. Lastly, XMPP can be used for notification services, where a user can receive alerts and notifications from an IoT device via an XMPP client. AMQP features and components. AMQP, or Advanced Message Queuing Protocol, is an open standard protocol for message-oriented middleware. It enables the secure, reliable and efficient transfer of data between applications or services, and is commonly used in Internet of Things (IoT) systems for messaging and communication between devices and servers. AMQP includes several key features, such as message queuing, routing, and delivery assurance. Messages can be sent between devices or applications and stored in a queue until they can be processed, ensuring reliable message delivery. AMQP also supports multiple routing strategies, allowing for flexible and efficient message routing between devices or services. Additionally, AMQP provides a range of security features, such as message encryption and authentication, to ensure the privacy and security of data in transit. AMQP is comprised of several key components, including brokers, exchanges, and queues. A broker is responsible for receiving and forwarding messages between devices or applications. An exchange receives messages from producers and routes them to appropriate queues based on message attributes. Queues store messages until they can be processed by a consumer. AMQP also includes a range of protocol extensions and messaging patterns, such as publish, subscribe, and request response, which enable flexible and efficient communication between devices and services in an IoT system. Overall, AMQP offers a powerful and flexible messaging protocol for IoT systems, enabling efficient and reliable communication between devices and services. Its rich feature set and extensible architecture make it a popular choice for IoT deployments where secure and efficient messaging is a critical requirement. AMP frame types. AMQP, Advanced Message Queuing Protocol, is an open-source messaging protocol used for reliable and efficient communication between systems. It is widely used in IoT applications for exchanging messages between devices and servers. In AMQP, communication happens through a series of frames. These frames are used to encode messages and send them across the network. There are different types of frames in AMQP, each with its specific purpose. The following are the main AMQP frame types. Method frames. Method frames are used to carry the methods of an AMQP class. They are the most frequently used frames in AMQP. Method frames carry commands and responses to commands, such as opening a channel, declaring a queue, or publishing a message. Header frames. Header frames carry information about the message, such as its content type, encoding, and length. They are sent immediately after the method frame and before the message payload. Body frames. Body frames carry the actual message payload. They follow the header frame and are used to transmit the message data. For large messages, multiple body frames are used. Heartbeat frames. Heartbeat frames are used to ensure that the connection between the sender and receiver is still alive. They are sent at regular intervals and are used to detect and close dead connections. Each frame in AMQP has its unique structure and purpose, and they work together to provide a robust messaging infrastructure for IoT applications.